so that we can help other people too. All right, so we're recording now. And still that light is killing me. All right, I'll just have to cope. So let's break this down a little bit. I wonder if I should. Okay, if we were writing C++, we might do this, right? Node constructor. Node : node. And I'll write it like this. Unsigned int payload. And payload. And I might say payload equals PL. And there's my constructor. Do we agree?
I'd say yeah.
All right, what's the problem with this? Let's see, struct node. I wonder if that's a red herring. But anyway, we're not really going to be compiling this. Oh, yeah, there's the problem. I forgot to say unsigned int. Okay. Here now it's going to agree. The line will go away. Now, what would that be like in assembly language? Well, it's going to be similar, but not the same. Let's do this and let's do that. Close this. So I'm going to start writing some assembly language here. Now all of you are on Wizzle, right? Windows?
Yeah, I am.
Okay. All right. So P2 align 2 and dot text and dot global main. Okay, so let's define the structure. Well, it turns out that all of this is syntactic sugar. I'm going to remove this and this for now. Okay, so all of this is syntactic sugar, right? This actually doesn't contain any code. All it's really doing is saying that when I finally declare a node and I want to access its members, this is 8 bytes at offset 0. And this is 4 bytes at offset. What is 8 plus 0 is 8. So this starts, this next one starts at 8. All right, now if there was another int, it would start at 12. But if the next thing was a long, it would start at 16. So the total size of this is 16 because it's going to be rounded up to the next boundary of a long. All right, so I'll just write that now. I'll say that when I refer to all wrong letters, off by 1 in the keyboard, node next, well, that's the offset of 0. And where is node payload? That's the offset of 8. So far, that's all the C compiler is done. And I'll put in size of the total size of a node is 16. Okay, any questions? So declaring a node, a struct, that's all this is all the compiler is doing, is just computing what the offsets and lengths are. Got it?
Yep.
Yeah. Now you're going to have the recording of this once it's done doing its business. And also, I can send you the files here. So what I want you to do is pay very close attention, undivided attention. Okay, let me at this point send an email to Quinn because he's not here. All right. Okay, so far, this is all I've done in the all the compiler's done is figure out the offsets and the widths. So if this was C++, there would be a constructor, right?
Yep.
So let's make believe we're writing a constructor. And I'm going to call it alloc node. And let me give some documentation. Alloc node will malloc the correct size. It takes as an argument the value to be stored in payload. Okay, I'm getting that from right here, right?
Yep.
Okay. It will return in X0 a pointer to the newly malloced node with the next pointer initialized to null pointer. Okay, that's what it's going to do. So I wrote the code first. I'm sorry, I wrote the comments first so that I'm telling myself a story about what the code is supposed to do. Notice it does very little. It does one thing. It allocates and initializes two things, but one thing. And by writing the comments before I wrote the code, I'm getting it clear in my head what it is that it's supposed to do. And it's like doing a one-person code review. I have listened to myself. I've written it out, and everything I've said and wrote makes sense to me, so I'm ready to continue. That's a good practice for you guys, okay? Oh, for some reason, these guys are all indented. Okay. All right, so boilerplate for any function. STP X29, X30 going onto the stack with a pre-decrement. And the first thing I'm going to write is the reverse. LDP X29, X30 off of the stack with a post increment and then a return. Okay, to make debugger slightly happier, I'll also copy the stack pointer into X29. Okay, so right now, where is this code going? I don't know. I think it's going, yeah, good. It's going to my home directory. So sample.s. Whoops, now I screwed up. I really screwed up. Let me change the name of that. And change the name of that to sample.s. Oh, do I already have one? All right, so this is going to be called foo.s. Now it's still named wrong. Rename foo.s. Okay, so this is gone. Let's open up foo.s and now we're back in business. Everybody happy?
Yes.
Any questions? Okay. So I have enough that I can test by just compiling and see if it builds. It doesn't have anything. So the only error I got was there's no reference to main, and that's true. So I didn't get any other errors. So I'm going to continue. All right, so I need to malloc the correct size. But where does the argument come in at? This arrives in X0. It takes the no, it arrives in W0. Why is it the 0 register? Because it is the first parameter. Why is it a W? Because it's an int. So now I see that I'm going to need another preserved register because the payload comes into me at W0. And once I call malloc, W0 is going to get blown away. So I got to squirrel away the original value of W0. So that says to me, I'm going to just need another register. Son of a bitch. It's so useful when it just tries to help. Just stop helping me. So put it on the stack. That is a pre-decrement. And I'll immediately reverse that with an LDR. X20 off of the stack. That is a post increment. And now I need to preserve W0. You see how I'm interchanging W and X? So I preserved X20. I could have preserved W20, but it's the 20 register. I'm using W20 on line 22 here because I'm backing up W0. That's the only reason. Okay, so now the payload is preserved. I can then set up the call to malloc. Now, how does malloc work? Well, go to your Linux editor, your WSDL editor, and you say, man, malloc. Ah, look, there's the manual for malloc. Okay, it's your responsibility to go do these things. Namely, I'm not going to, I have actually shown you how to use malloc, but if you've got questions about malloc, or you have questions about A to I, if you have questions about anything that's a pre-written routine that's part of Linux, you go to the man pages. What you see here is pretty much the same text that I read when I was 18 years old in the late 1970s. Granted, there's a few more functions added, but this is pretty much how I learned. This is how anybody learns. So you have to learn to learn. Okay, learn on your own. Professor's not going to be here for the rest of your life looking over your shoulder, telling you what to do. So the information in the man page is if you are writing in C++, you see what, are you seeing this? What are you, tell me what you're seeing right now. Can you see a window on the left? The editor?
Yeah.
Can you see the man page on the right?
Yep.
Okay, good. So if you were writing in C and C++, you know an include file. And here's malloc. Now, what can I learn? I'm writing in assembly language. What can I learn from just that? First of all, it takes as a parameter a size t, and that's a synonym for long. And it has one parameter. So that's going to be the 0 register, and it's going to be an X0 because it's a long first parameter. Next, I see that it returns a pointer. The return values are going to be in the 0 register, and it's going to be an X0 because it's a pointer. Then I could read about malloc, and then I could find out what malloc returns. Okay. And while we're here, let's talk about free, because if something has been malloc, it needs to be freed. Here's free on the next line. I can tell that it takes one parameter, so that's the 0 register. The type of the parameter is a pointer, so it's going to be X0. And I also see that it's just a void, so it doesn't return anything. Okay. And then I can read about it down here. Okay, so I have to put into X0, I'm using malloc now. I have to put into X0 the size of a node. So move X0, size of node. Okay, and what's that really going to be? That's going to be the value 16. And then I call malloc. Okay, so when we get here, I am going to, you know what? I'm going to just do this. Okay, now I got lots of room. When we get here, X0 contains 0 if the malloc failed, or if the malloc succeeded, it contains a pointer to the newly allocated memory. Any questions? All right, let's go back to the comments and explain what happens. If the malloc fails, a 0 will be returned to the caller. If the malloc succeeds, a pointer to the newly allocated memory is returned to the caller after having filled in a null pointer. I'm initializing next. And B, the payload in the payload space. Okay, any questions? Okay, so when I say, are there any questions, you respond with either a question or no.
No, not that I can think of.
Okay, good. All right, so now malloc returns something in x0, and the bad value is a value of 0. So I'm going to compare and branch if x0 is the value 0. And where am I going to branch to? 99F, and that's going to be right here. So let's see, according to my documentation, if malloc fails, a value of 0 will be returned to the caller. So if x0 has a 0 in it, I'm going to branch to the end of the function and return. So I've correctly implemented that part. So when we get here, x0 contains a valid pointer to the newly allocated memory. Now, I'm not saying it's the newly allocated struct, because it's just bytes. It's not a struct until I start treating it like a struct. So let me do that. I'm going to move. What am I going to move? I'm going to move W20. No, I'm not going to move. I'm going to store, because I'm sending it to memory. I'm going to store relative to that pointer that's sitting in x0 with an offset of node payload. Whoops, not capital P. Okay, I just initialized the payload. Any questions?
No.
Okay. Yeah, Donovan, you can say no too, all right? Because when I'm waiting for you, we're just wasting time. Okay, now the next thing that we're going to do is initialize next to 0. Okay, that's just going to be, oh, where do I get the value of 0 from? I've got to put it somewhere. So I'm going to move into, I'm making a mistake right now. You ready? Okay, what's my mistake?
I think you're storing 0 in x0.
And that's a mistake because
You just stored W20 there, and it's gonna get
no,
overridden.
no. I stored W20 into memory pointed to by x0. So if I wrote this, I would be blowing away the pointer.
Yeah, you'd be overriding the pointer.
Okay, so I'm going to put it in x1 instead. And now I'm going to store x1, which contains 0, into memory relative to the pointer x0 and node next. Let me check my documentation. If I were to drop from line 41 directly into line 43, I would be returning. Now, what am I returning? Well, X0 still contains the pointer, and that's correct. And at the memory found at that pointer, I have put a 0 into the node next, and I have put the payload into the payload area. Any questions?
No.
Good. All right. So what I just wrote is essentially this constructor. Okay. Now, what if let's make some progress on the actual project. I'm going to need to, quote, permanently store the head pointer to a singly linked list. And that's going to need to be initialized to null pointer. Okay. So what I'm going to do is I'm going to start writing main. And I know I'm going to need. Okay, here's Owen.
Hey, sorry, I'm late. I just got back.
Hey, you did a good job. So let's pick up where we're going here. Owen, the meeting is being recorded, so you'll be able to catch up on the first half hour, okay?
All right, thank you.
Okay. Good. So I need a head pointer. I know I'm going to need one. And so, oops, there's no colon in this. And oh shucks, because I'm a neat freak. Let me go back and do that. And that means I want to go here. And I'm doing this only because I'm a neat freak for my code. My code must be neat. Messy code means it's not understandable code. All right, so I'm going to use X20 as my head pointer. And let me start writing main. So main. Owen, are you on a Macintosh?
No.
Okay, good. All right. So here's main. First thing I'm going to do is back up my registers. STP, X29, X30, off of the stack pointer with a pre-decrement of 16 bytes. I'm making use of X20. So let me store that away. I got to be able to clean it up when I'm done. Minus 16. Okay, so let me set up for the reverse. And that would be an LDR because it's an STR that I'm reversing. Off the stack pointer with a post increment. LDP, X29, X30, off the stack pointer with a post increment. Move to W0, WZR, and return. Okay. All right. Now I have written more than enough to do a test. And my test at this point, I can only test two things at this point. A, do I have any syntax errors? And B, will it run and exit after having done nothing? That's worth testing. You write a little, you test a little. So GCC foo.s. Okay, I can see that it compiled without error. Let me try running it. It should do nothing. Okay, first test complete. Well, it's the second test, but it's the first test for main. Okay, so let me write another function. Let's go to our now, if I was writing C++ here, in this case, I wouldn't have to write a destructor, but let's make believe we were writing one. So that's how you declare a destructor, right? And this is how you would, in this case, oh, come on, keys. Hey, look at that. I don't need to add any code. If this were C++. But I'm not writing C++, and I do need a destructor. So what is it in essence a destructor? So I am going to write one. First thing I'm going to do is the documentation. Write the comments before the code. Freenode takes a non-null pointer in x0 and calls free, and that's all it does. All right, so Freenode. Once again, got to do my boilerplate. Every function needs some boilerplate. I'm going to copy those 3 lines and then delete because I don't need x20. Hey, here's a good reason. Here's a good demonstration as to why you have to back up registers. So in main, I'm using x20 for the head pointer, but check it out. In ALEC node, I also used x20 as a temporary register. So notice that that's all okay because ALEC node pushes x20 onto the stack on line 47, and it restores it from the stack on line 63, so that the value coming into ALEC node in x20 is my head pointer. And when ALEC node, when I finally do call it, when it returns, the head pointer is still in x20. You see why you back stuff up and restore it?
Yes.
Okay. Oh, and the protocol in this meeting is if I say a yes or no question, then you know, if I say like, do you have any questions? You got to say no right away because I don't want to wait for you wondering if you have a question or not. So everybody keep your microphones on, and that way we go as efficiently as we can. Okay, so where was I? Oh, yeah, I'm writing Freenode. So let me get in some more boilerplate. And that would be this. Put it here. Very good. Now, I want to do a little defensive programming. So the defensive programming is to be defensive, this function will check x0 to make sure it is non-null. And if it is null, just return. Okay. Okay.
Okay.
Yes.
Okay.
All right. All right. So here we are. According to my documentation, free node arrives, X0 arrives to free node with, it should have a non-null pointer in it. So I'm going to compare and branch if 0, X0 to 99 forward. Let's put in 99. Okay. Okay.
Okay.
Okay.
Okay. So when I say okay, for example, that's your opportunity to say, I have a question. All right. Or no. Okay. Right. So I just implemented with this one instruction, I implemented this. Okay. So if it, when we get here, we have verified that X0 contains a non-null value. So let's pass it to free. Take a look at these comments. When we get here, when we get here, so I keep using that phrase over and over again. And I'm talking to myself, and I'm talking to future readers of this code. And I'm describing what's in my head. I'm telling myself the story of this code using these comments. All right. Now, to call free, what do we need to do? Man free. And that's the wrong one. So you would say, let me show you something about the manual. I'm going to say man. And here are the chapter numbers. So when I said man free, I got the documentation for something else that's called free. In order to get the correct documentation, I need to say man 3 free. Okay, so my parameters, there's only one parameter, so it's the 0 register. And then I noticed that it's a pointer, which I knew. So it's X0. Fortunately, I look here and I see that X0 comes into us with the pointer. And then it doesn't return anything. So all I have left to do is there, I'm done. I'm done with free node. Okay, and I even included a little bit of defensive programming. Okay. Now, the test that I can do right now, you only write as much code as you need to get to the next test. Never more. Well, in general, never more. Just like the Raven. You have no idea what I'm talking about, do you? Anybody?
I don't.
No.
That was a pun.
Yeah, well, Nevermore is from Edgar Allan Poe, The Raven. The Raven keeps repeating Nevermore, Nevermore. Okay. A dot out. Okay, so there's my test. Notice that main still doesn't do anything. So what I was able to verify is that I don't have any syntax errors, and that's worthwhile. It only took me 10 seconds. Okay. So what kind of, I now have code to allocate a node, and I have code to free a node. Why don't I test that? So test allocating and freeing a node. This code is purely for testing. It won't be used in the final project. Okay, and it's okay. I'm going to take a little extra time to write a little extra code just for testing purposes. The time that it takes me to write this code is smaller than the time it would take me to debug later. That's why I'm doing it. And in fact, I will move this to its own function so that I can leave it in the code in case I want to test again later, like a year from now. Maybe I changed something and I still want to test. So here is test alloc free. And let's get in the boilerplate. And oh, here's some more boilerplate we were supposed to have. Move X29, copy the stack pointer over to it. That's boilerplate that I need. And oh, good heavens, I'm off by a space. Okay. And to use the test, I'm going to do this BL to test alloc free. Later, all I have to do is comment that out, and then the test is gone. But I can leave the code for the test in the program. Once again, yeah, I'm doing extra work. My claim is this extra work will save me time in the end. Okay, so attempt to allocate a node. Let's see. Look at my documentation. It takes an alloc node takes an argument, which is to be stored in the payload. Okay, let me do that. I'll set that up. That's supposed to be in W0. So move W0. I don't know, something recognizable. So other than 0, 0, you know, if I see the 17, I know it's correct. Okay, BL, alloc node. And when we get here, X0 must be non-zero. Okay. So I'm going to come down here. Dot data. And I'm going to say bad malloc. Dot ASCII Z. Malloc failed. Dot end, since I'm here. Okay. So back to my test code. I'm going to compare and branch not 0 to, and I'm looking at X0. And I'll go to 10 forward. So here's 10. So if we get here, malloc failed. Print a message. Bad malloc. And then call puts. So BL puts. What's the manual page for puts? Man puts. Okay. There. So it takes a pointer to a string in X0, and I don't really care about the result. And now branch to 99 forward. And here is 99. Okay. When we get here, there's that phrase again. Alloc node has allocated something. Test. Oh, okay. The something is in X0. Test by looking at the memory pointed to by X0 to make sure the next is null pointer and the payload is 17. Right? If we're writing a test, let's write a real test. This, by the way, is an example of a unit test. We are testing only malloc and the allocate and the free. All right, so how do we do that? Well, let us load the value found at X0, or I could also say node next. And compare and branch 0, X1. I'm dereferencing X0 with an offset of 0 and putting what was in memory at that location into X1. So I'm going to look at X1 and make sure that it is 0. So compare and branch of 0 to 20 forward. If we get here, next is non-zero, which is a bug. All right, so I'm writing my code here. Bad next. Not ASCII Z. Alloc node didn't zero out next. No, I used puts, so I don't need that. Okay. Who's got questions? Anybody?
Nope.
I don't.
Quick question. Do you need to do the like LDR, LDP and return at the end of every like function that you have?
Right. So every function has boilerplate at the beginning and has some boilerplate at the end.
So is alloc node just like a label then, or is it separate?
Alloc node is a label, and we're going to treat that label as a function.
Okay.
So what I mean by that is if I say BL to a label, I'm treating that label as a function.
Okay.
Okay, because the BL is, that's what it uses. That's what it's used for. It's for calling functions.
Mhm.
Other than that, it's just an address. Okay, so where were we? If we get here, next is non-zero. So let's load up our error message and say into X0 because I'm using puts, and it's going to be bad next and BL to puts, and then branch to 99 forward. And here's 20. When we get here, we have verified that alloc node did put null pointer into next. Now we will check if payload contains the value we expect, which is 17. All right. So how did I get next? I did a dereference of X0 plus the offset of node next, which we all know is actually 0 because it's the first element of the struct. And we put that somewhere. So let's dereference LDR. Now the type of the payload is an int. So that's going to go into W1. Dereference X0 at the offset of node payload. Okay, and then compare. To do the compare, we have to move into W2 the value of 17. And now we can compare W1 to W2. And they better be equal. So branch, if they are equal, to 30 forward. So what do you think I'm going to write here? If we get here, we didn't find the value 17. We were looking for a bug in alloc node. So let's see. Bad payload. Just to be consistent. All right. LDR X0. Bad payload. BL to puts. And the next thing I want to do is to okay, branch to 99 forward. That's the exit. Means when we get here, line with label 30. When we get here, we have verified alloc node did all the right things. Now call free node. And test that by using Valgrind on Linux. Okay. So let's see, in order to call free node, we have to have our allocated memory in X0. So is it still in X0? So let's see, BL alloc node. So it comes back in X0. We'll only destroy X0 if there's an error. And so X0 is still valid. We'll only destroy X0 if there's an error. X0 is still valid. And we jump here. We only destroy X0 if there's an error. So X0 is still good. All right, so I'm going to call free node, and my test is complete. Who's got questions?
Not me.
I don't.
Okay, so now I'm ready to actually run. And let's take a look. GCC, and just in case, I'm going to put the debugging options on. No syntax errors. And let's just run it. Okay, well, that's a problem. Notice I didn't get any of my printouts. So that suggests to me, the first thing I'm going to do to debug is to check to make sure I have all my pushes on the stack balanced with pops off the stack. So let's see, I called this store pair, store load pair. Okay, that's balanced. Let me come down here. Okay, there's my bug right there. It's a typo. Instead of 29, I've got 20. All right, I made a change. Let's test it. Okay, there's more than one bug. Okay, so I do a store onto the stack, and there's, look at that, the same typo. Okay, and as a matter of fact, here's the actual bug. Here's a store pair, and then down here I have an LDR and the load pair. That's not supposed to be there. Okay, so I had a bug with my bug. Okay, build it, run it, and no output. That's the correct result. But let me check the value. Let me check the functioning of free node by saying valgrind a./a.out. And there's my good output. You see that? All heap blocks were freed. No leaks are possible. Let me show you what would have happened if I didn't free what I mallocked. So you see what I did there? I commented out the free. Okay, so build it again. Run it in Valgrind. Whoops. There's my leak. All right, let me make sure I uncomment that. Build it again. Run it in Valgrind, and all freed. No leaks possible. All right, now I have written quite a lot of code here. And I have actually written the code to allocate and free nodes to fill in the values. So this is directly usable in your project. And this is directly usable in your project. If you want, you could include this test harness, this unit test, but it won't be part of your project. What are your remaining questions?
So when I tried building my program, it said malloc failed.
You typed in this, this code?
Yeah, I typed in the code over there and it's
Okay,
saying
yeah, so
malloc failed.
you probably have a typo. So here's what I'm going to do. I'm going to email all of you this code right now, okay? And so Mitch, try that, okay?
Okay.
All right. Start page. Okay, so who's here? Mitch Berg and Owen Bengal and Donovan Frazier. Okay, and here comes your code, and here comes G and that. Upload and send. Okay, so while we're waiting for Mitch to try out the code I just emailed, who else has a question?
Yeah, I had a quick question about
Go.
like how when you allocate the first node, I'm assuming you assign that one as the head at the very start, correct?
Nope. What happens if so make believe I have a full project and I'm about to test it. So what happens if I just say this? It's not supposed to allocate any nodes. So the head pointer should still be null. What happens if you do this?
Well, that
That's
shouldn't even get to the allocate part, right? Yeah.
Yeah, see?
But what my question is I guess if you don't keep track of the head pointer when you put in the first element that's able to be used, how would you go and assign the head to a new node, or basically saying after you allocate a node, how you can say this struct's next pointer is this.
Okay, well, you do it. I think you do actually know the correct answer. So I had interrupted you because of a technicality of what the words you used, but I think you actually do know the answer. So let me try to model the answer. So suppose we have discovered the need to insert. Okay, so first thing, so therefore, we need to figure out where to insert. And I'm going to start a multi-line comment here so that I can just keep writing.
Because my question was more along the lines of, if you don't keep track of the node before or after, if there are any, how do you even know where it would be supposed to go? Because a node doesn't know its previous
right
one.
Right. So yes, you will need to keep track of that. So already I have set aside X20 to hold, and look, I backed it up and I restore it. I have set aside X20 to keep track, so to speak, permanently, the head pointer. And that's a bug. That's supposed to be X29. And begin by initializing the head pointer to null pointer. And that's going to be move head
X20.
pointer with XZR. Yeah, or in other words, X20. Okay.
Wait, a
Then,
quick like
Yeah.
interrupt. What is the difference between .EQU and .REQ?
okay, so I don't know why, but to give a different name for a register, it requires .REQ.
So it's basically like a variable name for a register.
Exactly, it's an alias for a register.
Yeah,
Right.
okay.
Right. Yeah. And .EQU just creates a symbol that will be replaced by the second argument.
Okay.
So when I say node next, it really means 0.
Yeah.
When I say size of node, it really means 16. Similarly, when I say head pointer, it really means X20.
Yeah. Mhm.
Okay. Mitch, how you doing on that code?
It worked.
Okay. So if you do a comparison, I'll bet you find there's something that you made a typo on.
Yeah.
Okay.
So what I was initially doing was I was just filling in the payload, and then I would set the next address to 0 because in the case of it's the tail, it doesn't need to point to anything.
Yes, and
But
that's exactly what I did. So I don't think that you were here for when I wrote this code. So let's take a moment to review this code. Okay, so the first thing I do is I write the comments. I write my comments before I write my code. The value of doing that is to hear yourself think. It's like, do you know what a code review is, everybody?
Yes,
Yeah.
I do.
Okay, yeah. So a code review, kind of code stand-up, is you get in front of people and you explain your code and other people criticize it, hopefully constructively. So when you write your comments before you write the code, you get to hear yourself think, you get to see yourself, what your thoughts are, and you're explaining what you're about to do to make sure it makes sense.
mhm.
Okay, so after I wrote the documentation, I then started writing the code. And after I've written the code, I can make sure it conforms to my documentation. Okay, so here we are, boilerplate, boilerplate, boilerplate. And I'm just checking to make sure it matches the boilerplate. Okay. I'm initializing W20 with the payload. Now, hey, it's okay. See, I'm using W20. I'm using the 20 register for the payload here, but wait a minute. I've already said that the 20 register is going to be the head pointer. Is that a bug? No, because notice that first I backed up the 20 register and then I restore the 20 register so that while I'm inside this function, I can use the 20 register for something else. You got that, Owen?
Yeah.
Okay.
So what is the X0 size of no? What is inside X0?
Okay, so size of node, that's 16.
Oh, I thought it was like a size of like function call. Okay.
Exactly. Exactly. Good question. All right, so I put 16 into X0 and I call malloc. When we get here, if X0 contains a 0, the malloc failed. So I'll return the 0. All right. Reminder. This function might return 0 for malloc. Failure. Notice we are not handling the error. No, we are not handling the error. The caller must check and handle the error if it occurs. Okay, because here, look, we call malloc, and if malloc failed, we just return. Now, what are we returning? When we return with the error, X0 still contains 0, so the caller has to check X0. And did we do that in our test code? Let's see. Yes, we did. So if we called alloc node, and if it returned 0 for failure, we would have printed an error message. So there, I'm modeling the right behavior for you. Okay, and then just like you said, so that's why I'm confident you do understand this. I hope you do. You tell me if you don't. I call malloc. I make sure it returned a good value. I put the payload into memory. That's what str does. str, stp, ldr, ldp are the only instructions that you're aware of that touch memory. Okay, so I'm putting the payload into memory at locations starting at the value stored in X0 with an offset of 8 bytes. And then I'm initializing, I'm putting X1, 0, and there is my null pointer into node pointer next.
So do you always have to, I guess, store an extra register for the previous node and just like not touch it so that it would know, I don't know, to put it after?
Okay, so I know where you, I think I understand your question. You are correct in that when you have a singly linked list, nodes don't point backwards. So as you traverse the list, you have to keep track of the current node and the previous node.
So I guess my question actually then is, how do you traverse through the list in assembly?
Well, how would you traverse through the list in C++?
You would just say, well, at first then the current node is the head, and then the current node is the current node's next.
Right? Okay, so I'll write that. Void, I'm just making stuff up here. Traverse list. And it's going to start out with node star head pointer. Correct?
Yeah.
So far? Good. And so I'm going to say node star current node. And that's going to start out with the head pointer. and node star previous. And I'm gonna do what I usually do because I like lining things up. And that's going to start out as null pointer because there is no, at this moment, there's no previous node, right?
Yeah.
Okay, good. So if cur, well, all right, let's let me see, let me just try this and see if it makes sense to me. While the current node is not the null pointer, previous node equals current node equals current node next. Okay, so I think that that will traverse the list. What do you think?
Yeah. I mean, I would have just said the current node's next is null because wouldn't you not be able to get to there's no next pointer in the tail.
I'm not keeping track of a tail.
No, I know, but the tail is just the part that points to null and not to
Okay,
another.
so let's say the current node was the last one, right?
But it would still, oh, I guess I see it now, yeah.
Right, so if current node here is the last one, that means its next value is null. That null gets set to current node, sets current node, which ends the loop, comes back up here, and
Oh,
there
okay.
you discover your null and you stop.
Yeah.
Okay. All right. So in the assembly language, this is coming to you in that's stored in X20 based upon what we've written so far.
Yeah.
Right. And then you'd create another, you'd use another register as prev node. So maybe X21.
But you wouldn't store it. Why would you not store it?
Well, you are storing it. You're storing it next in another register.
Oh, okay.
Well,
Okay. Yeah.
Yeah. Now remember, that means in your function that traverses the list, you're going to need to back up X21 onto the stack and then restore it at the end. You know what? I'm going to take this and I'm going to write this in assembly language. Now, I feel comfortable doing that because it doesn't really do anything, does it? It just models what your question is.
Yeah.
So, okay, so there's the code I want to emulate. Okay, so traverse list. And let's get in our boilerplate. Right. And so it looks like I'm going to use X21. And let me go here, get that boilerplate, fix this up. And okay, so and also not just X21, I need 21 and another one. How about 22? Whoops. And okay, and why? Because X21 will be used as cur pointer. Cur node. Did I say cur node or oh, I'm looking at the code right there. Cur node, and X22 will be used as prev node. And okay, so MOV. And you know what I'm gonna do? I'm even gonna do this. I'm gonna say cur node dot rec. What did I just say? Current node is x21. And I'm gonna say prev node dot rec x22. And now I can do it symbolically. So cur node gets the value, come on, fingers, of head pointer. And prev node gets 0. Okay, so I've just implemented these two lines. Got it?
Yeah.
And isn't it cool how the assembly language is the C code?
Hmm.
You know, C is really in a high level assembly language. That's what it is. Okay, so what's next? I have a while loop, so that means the loop, it's a loop and it has the top of a loop. So I'll put in a label. And cur node not equals null pointer. So current, that's the same as saying cur node isn't 0, while cur node isn't 0. So compare and branch if it is 0. And what am I testing? Cur node. And where am I going to go? I'll go to 99 forward, and here is where 99 should be. So there's that. Then let's do prev node equals cur node. And that's just prev node gets the value of cur node. Okay, I just implemented that. So come here. All right. And okay. And now I need to do cur node next. Now, next, so now I have to go to memory. And I have to load something from memory and assign that to cur node, which is in a register. So I can do that in one instruction. LDR, putting the results in cur node from memory, starting at the old value of cur node with the offset of node next, and then branch to 1 backwards. There we are. How you doing, Owen?
Yeah, it's good now.
Okay, Donovan?
Doing good.
Mitch?
I understand.
I'm good.
Good. All right, we are all of us are good. It's been 90 minutes. Do you have any more questions?
I have a question. So for labels in general, do they have to be Like when you write them, do they have to be the same line as the starting code for that label, or can you put in the label and then the next line is a code for it?
Yeah, you can do that if you want.
Okay,
Okay.
thanks.
So you see, I have an example of both here. This one is a label where the code's on the next line. And this one is a label where the code is on the same line. So you see, it doesn't matter.
Okay, thanks.
Okay, now the way that I tell the difference is my preference is for on the same line, but this didn't fit. And that's it. Mitch, questions?
Yeah, I just tried building the program here and it says I have an undefined symbol used as an immediate value. It's in the
Oh.
traverse list.
Okay. Okay. So very, very carefully. Well, first of all, let me test because I didn't try building this yet. So maybe I made a mistake. So I'll go here and okay. So let me go to line 155 and see what I did wrong. Oh, yep. See, I did something wrong. Remember, I realized later that I needed to do 2 registers. Well, that means it has to be an STP and an LDP for 2 registers. And okay, now it's working. Now try making that change and see what you get.
It says the errors where we load the current node to be equal to the next node.
This line here.
Yep.
Okay, LDR, right? Check your spelling, CURR_node and NODE_next. Then check here, there's CURR_node. And then make sure go to the top and here's NODE_next.
Yeah, it works now.
Okay, and the universe is complete.
I actually have another question.
Go ahead, Donovan.
So I was following along and I tested it out earlier and it says illegal instruction.
Mm-hmm. Now, when you say you followed along, that means so you were trying to type as I typed?
Yeah, similar.
Okay, so I'm gonna send a second email with the current code, and then I'd like you to try it, all right?
Okay.
Because if it works for me, and it doesn't work for you, but it's supposed to be the same, well, then it's not the same.
Okay.
Okay, so DF and OD and MB. Next version and attach. Yeah. Okay. No, I didn't hit send. Huh. All right, and it's thinking about sending. You guys know how when Google Mail says undo the mail?
Yeah.
Undo is you know how the undo is implemented?
Yeah.
Yeah, how?
I'm yeah, I'm not exactly sure how.
Yeah. It is, I'll tell you, it does it by lying to you.
Oh.
So when it's still offering you the choice to undo, it means it hasn't actually sent the mail yet.
Yeah.
Yeah, there you go. Okay, so Donovan, you have the new code.
Yes, I do. I'm gonna test it in a minute.
Mm-hmm.
Just
Now let me check my phone. And oh, they've added a parking spot behind Straz. Ooh, they added one. Yep, that Professor Mahoney texted me a picture of a new parking spot. He said, "I think I found your new parking spot." He said, "Absolutely right."
Just
They
one
had,
spot.
yeah, they added a handicap spot behind Straz, and God damn it, if that's available, I'll take it. All right, so what was I doing? I was checking on my car. My car's it's brand new, and it had some teething pains. I'm not upset. Stuff happens, right? But
Yeah.
what's cool is I can, because it's one of these cool modern cars, I'm going to check in on it. So let's see. They drove it again. And it is currently the car, one of the windows is open and the engine hood is open. And the car's unlocked. So anyway, they're still working on it. Yeah.
the code works.
Okay, I was confident that it would. All right, gentlemen, three of you. Do you have any final questions?
How would we exactly like detect which node like to delete or yeah, which node to delete when we're traversing? Like, do we just use a different compare?
Yeah. So let's see, we're still presenting this screen, right? So I'm going to change this. You know what? I'll leave it there, and I will add another set of pseudocode here. And it might look like, okay, so I would write, once again, I write my comments before I write my code. Okay, so this is going to be, I just wrote the documentation there. So it's, let me change that. Okay, and remember that remember that the list is sorted. So if we only need to traverse as far as A, the end, or B, a node whose payload is larger than the one we're looking for. Is that enough for you?
Yeah, that makes sense.
Okay.
So that'd probably just be a compare in two separate branches.
Yeah, so here we have this satisfies, either we get to the end. So if we get to the end and we haven't found what we want, yeah, we would actually, well, we need to add this return car node. Let's see. Yeah. Cur node. Well, I don't want to write this whole function for you.
Yeah.
Okay. So we could put an and or and here. Something about this, the payload.
Yeah.
Or maybe we could look at payloads here and use a break statement, right?
Yep.
Okay, you got it.
All right.
Okay. One last chance.
No questions.
Yep, speak now or pick up the pieces.
Nope, I'm good.
I'm good.
Okay. All right. Did you guys have a good time?
Yeah.
Yes.
Yep.
All right, good. And I'm really glad that we were able to do this from, think about the time we've spent. Now it's 104 minutes. And think about the impact on me if I had to do 3 times 104 minutes.
Yeah.
Okay, so thank you for meeting together. Okay.
Mhm.
And with that, I think we'll wrap up.
All right.
Okay.
Thank you for the help.
Thank you.
Okay.
Yeah, thank
The recording will be available online once the Zoom company finishes processing it, and then I'll send the class a link. Okay.
Okay.
Good.
Okay. Bye, everybody.
Have a
Bye.
good
All
day.
right. See ya.
Soon.